Hi, this is an introduction to functions, what they are and how to work with them. So you're in class and you've just been given your first function homework assignment, and it's not really making sense. There are a whole lot of moving parts. There are F's and A's and X's. It doesn't really make sense. Well, first I want to decompose what a function is, and then I'm going to give you a couple helpful hints and tricks for dealing with different types of problems that you might be given with functions. Right, so the first is, what is a function? I like to think of it at its simplest, kind of like an assembly line in a factory, right? And there's this, and say I'm making toys. This is my very crude attempt at a toy. And all my toys go through a machine where I do something to them. I could, stamp them, or like add an arm, or do, one type of thing. And they will go through that machine, and they will come out with that operation done to them. So they'll be stamped, or they'll have an extra arm, or whatever, right? This is exactly what a function does. It takes in an input, or something like a toy. It does a specific thing to them, then it outputs, that toy with that thing done to them. So, how do we express that algebraically? Right? How do we turn this diagram into an equation? We usually have something like this: f of x equals something. Right? This f just refers to the function name. It could be g, it could be o, it could be really any letter, it could be multiple letters. That just represents that there is a function. And those parentheses surround my input, which in this case is an x. But it really could be anything. It could be a b, it could be a c, or it could be a number. And then it'll have next to it an equation. So let's say 3x minus 2. What this basically says is, hey, I have a function, I know that because I have an f and then parentheses, with a type of input like this. And for that input, I want you to do this to it, right? So I could have another function like g of c equals 3c squared. And that basically means, given a function I have called g, with an input c, do this to c. And now a key important thing to note about these types of functions is that for every input, they will only ever have one output, right? Just like in my factory example, given every toy, I will only have one output, that toy with that thing done to them. I won't have, if say I put a toy and I put it through a stamping machine, I'm always going to have a stamped toy. I'm not going to have a toy that's stamped and with 2 extra arms, for example. It just doesn't happen. So every function has to be so that given one input, it has exactly one output. Given one value of c, right? C equals 1 or c equals 2. For all inputs of c, they have to produce a single output, right? We can't have, if I plug in c equals 1 into this, I can't have this be 4 and 5. No, it has to be a single value. And if it doesn't have a single value, if we plug in an input and we get more than one output, it's not a function. Now, there are 2 main types of functions, and you'll get asked about classifying these a lot. There are continuous functions and discrete functions. And discrete functions, we'll start with those, are separate. They're unconnected, right? They're basically a function with a whole lot of points. They aren't connected and they're distinct from one another, right? So if I had a graph like this, that would be the graph of a discrete function. They're not my points on that function are not connected, and they are very, very distinct. Now, this is a discrete function. I'm going to throw in a challenge here. What if I had something like this? You might see this on homework where they'll give you a graph and they'll say, what type of function is this? Or is this a function? And in this case, it's actually not a function. Because remember, a function has to have, for all inputs, for every input, exactly one output, right? So in this case, since I input an x and I output a y, because if I were to graph this, I'd say y equals something, so on and so forth, right? For an x of say 1, I have 2 outputs. And for an x of say 5, I have 2 outputs. That's not allowed. So this graph isn't a function. But if I erase these points, if I remove them, it would be a function. This relates to what we call, at least in graphing, the vertical line test. If you were to draw a vertical line through every point on your function, on your graph, you will know if it's a function or not. If for every point, the vertical line goes through a point in your function exactly once, then it's a function. But if it goes through points on your graph more than once, twice, 3 times, 4 times, then you know it's not a function. And so this can be especially useful when you're asked to identify, oh, hey, this is a function. Or better yet, what points would you have to remove to make this a function? Right? You can perform a vertical line test and say, oh, this line, on this line, vertical line, there are 3 points. I need to remove 2 of them to make this a function. Now, continuous functions, on the other hand, are something that you're a lot more used to seeing, right? If you graph vertical lines or linear lines, you're pretty used to seeing continuous functions. They're functions where every point is connected, and points on this function can exist for any values within a set or infinite interval. In this case, when we're graphing y equals x, we're graphing it for all values, right? From negative infinity all the way up to positive infinity, right? So a huge range of values. But a function would still be continuous if I said, well, I'm graphing this from 5 to 7, as long as I had it pass through every single value from 5 to 7. Something like this would also be continuous. The best way to tell if a function is continuous or not, or at least the easiest way, is to know this. You can draw a continuous function without lifting your pencil up from the paper. If you can draw it, it's continuous. So something like this, right? I know it's a continuous function. I can draw it without lifting my pencil up from my paper. But something like this, I cannot draw without lifting my pencil up from the paper. So I know it's not continuous. Those are the basics of functions. And I hope those rules and strategies will give you a couple tips for dealing with functions in homework assignments. Saying, oh, is this function continuous or discrete? Or, oh, what is a function? How do I find values with it? I hope you found this helpful, and I hope you have a great day.